Hi everyone, today we're going to solve another problem, that is LeetCode 2 2246, longest path with different adjacent characters. So let's see what this problem is. First of all, it's a hard level problem actually, and it has a very good like to dislike ratio. As you can see, 2000 like versus only 53 dislikes, which is very good, and it is a very good problem. Although I will say having an intuition for this problem is not that difficult, but it has some, I will say, like a little bit tricky implementation, and there are some edge cases which could have been ignored if if the implementation is not done thoroughly. But we will do it, we will solve it. And let's see. So you are given a tree that is a connected undirected graph that has no cycle, which means it's an n-ary tree rooted at node 0. So 0 will be a root node consisting of n nodes numbered from 0 to n minus 1. The tree is represented by a 0 indexed array. Okay, so you are given a parent array, and for example at this index, that is 0th and minus 1, which means it's a root node, and first index parent is 0, second index means second node parent is 0. Okay, since node 0 is the root, parent of 0 is always minus 1. You are also given a string s of length n, where si is the character assigned to a node. Okay, for example, this is 0th node. At 0th index you are given a, which means at 0th node the character associated with this node is a. And return the longest path in the tree such that no pair of adjacent nodes have on the path have the same character assigned to them. Okay, so let's discuss a solution for this. So I will say that let's focus on this tree, and if we have to generate a path, then if we start from this area, that is the first node, I will can I go in this direction? I cannot. Why I cannot? Because a and a, they are same, so I will not be going in this direction. Can I go in this direction? Yes, you can. I can go in this direction, and then I cannot go in this direction. Why? Because b and b, they are same, so I will not be going in this direction, which means I will backtrack and then I will go in this direction. And when going in this direction, I can go in this direction. B and C, they are different, so I can. And this is one length that I have achieved, and this is the longest length, but it is from root node A. If I will take the length from second node, it will be 1. If I take the so from let write it here, from 0th node, the longest chain that you can have is 2 edges but 3 nodes, which means it's 3 chain. The length is 3 of this chain. From one node, the longest length that you can have is b to c, which means only 2 nodes, which means 2 length of the chain is 2. And from 3 we can only have one chain, that is 3 only, and 4 we can only have one chain. From 2 we can only have one chain, that is a to e, that is 2 to 5, which means 2 length of the chain. And from 5 we can only have one chain, that is 5 itself. Now the maximum length out of these values is 3, so 3 is my answer. And if I have to draw the chain length again, then it will be something like this, that from a, b, and then c. This is the answer for this test case. Let's run it on different test case. And in this one, we have this node, right? Now let's start from 0th point, and at 0 yes, I can go to b, fine. And at 0 I can also go to a, right? This is the chain. This chain means either you can start from 3. This chain means that you can start from 3, and then you have 0, 3, 0, and then you have 2. This is the chain, and the length is 3, right? So can you start with 0 to 1? No, we cannot, because this is a, so we cannot have this chain, because a and a will give us a problem. So this is the maximum chain, which means that from 0, the maximum chain that you can have. Okay, now I will not say from 0, starting from 0. I will say the contribution of 0. If I am including 0th node, the maximum chain that associated with 0th node is 302, which means 3 length. And if I include 3, if I take the contribution of 3, then it will be 3 again. But if I say that starting from 0, then it is only 1. Why? Because either it can be 0 to 3 or it can be 0 to 2. It is of 1 length, maximum length is 1 only. But if I say starting from 3, then there is no chain, which means 1. Actually, this will be 2. And this will be 1 only because 3, the third node is only counted. And I hope you are getting the concept. So the concept is that we need to have some type of chain, some type of path which doesn't have which in which the adjacent characters that are associated with the nodes are not same. Which means you cannot have like this A C B. This is not true because C and C are same. You can have A B or C B A B C, right? This type of node. And in this tree, the node is C A B, C A B, C A and B. This is the node that you can get. Now you can say that it's starting from 3, or you can also say that it's starting from B. One and same thing. The path is this. Okay, now we have this clear how we can solve this. So I think most of you can understand that this is nothing but a graph, right? An array tree is a graph. Well, that is done in the while we are reading the problem statement, we can easily observe that this is a graph problem. Other than graph, we are traversing on the graph, right? So which means that this could be solved with DFS. Can it be solved with DFS? Yes, it can be solved with DSN, and let's see how. I will say that at every node, let's say n, and it has a left child and it has a right child, right? I will say that there are two possibilities for n. For n, there are two possibilities. Two possibilities. Now, possibilities are chain starts from n, from nth node. This is one possibility, okay. Second possibility is nth node is not a start or end node, right? Which means that if we have a node like this, let's say K, L, M, N, and then we have O. Now nth node, this is a second possibility, but if we do not have a node O, then it is at the end, then it's a first possibility thing, right? Otherwise, if we don't have KLMN and we have N, M, O, we have, let's say, N, then we have M, then we have K. Now this is a start node, which means this is a first possibility. So there are two possibilities associated with every node. Okay. Now there is a thing. If I say that there could be multiple children, right? There could be left child, right child, or some middle child as well, right? So what I will do is, if a path that is the longest chain that is associated with the left child, that is one of the child, and the second largest chain associated with the other child, I will have now two options. Either a node, either the chain is starting from root n, or the chain is not starting from root n, but there is a largest chain from one of the child, and then there is another largest chain, the second largest chain from the any other child. Then I will add them up. So I will say the largest chain length from child, by the way this length is from the child, and the second largest chain from the child plus 1. This is one possibility for if nth node is not a second number. But if it is a second number, then the second largest chain will be 0. So we can use this formula also for the chain that starts from the nth node, right? Because second largest chain will be equal to 0, and if it is equal to 0, then LC plus 1. LC means the longest chain that is coming from one of the children, and plus 1 means the node itself, which means this formula will work. So let's see how we can implement this. By the way, this is just nothing but a DFS traversal, and in DFS traversal, the time for this code will be order of n, that is the number of nodes, and space complexity will also be somewhere equal to n square, because we are going to use a graph data structure or an adjacency list. So the worst case it can have is n square space. So let's solve this. We have a vector int graph, and size will be equal to n. Now what is n? So int n is equal to graph dot size. Now we need another variable, that is int max chain length, that is equal to 1, because it will be I mean the least value that it can have is 1, because one of the node will be counted, and it is given in the constraints that we will have at least one node, so the least value it will be equal to 1. Now we need to create a graph, so I will say int I is equal to I is equal to, well, we don't have to give I is equal to 0. Why is it so? Because 0th parent will be 0 itself, or we don't need to have -1, and we are also not going to start our traversal, we are not going to start a traversal from any node that is parent of 0, because there is no node that is parent of 0. So we can start with I is equal to 1 and I is less than n, I plus plus. Then I will say graph of, so parent of I dot pushback I. Now you will be saying that it is given in the question that it's an undirected graph, right? But tell me one thing, are we going to travel when we are in a graph, when we are traversing in a graph, are we going to travel to the back? Uh, I mean, are we going to travel to the parent node or an ancestor? No, we are not. We will be backtracking, but it's not traveling, right? It's not traversing on the graph to an ancestor node. So we don't need an undirected edge. We can only have a directed edge. That is what I am having. So these edges, when I'm creating this graph, these edges are like this. They are not like this, but they are not like this, but they are like they are flowing in the downward direction. So after having this graph created, then I will say DFS on graph starting from 0th node, and we also don't need a parent for this one, because it's very obvious that it won't be going back to the ancestor, so we don't need parent. And then we have s, that is the string, and we have max length, max chain length, and let me change the order. Yes, s first, and then we have the node 0, which we are starting the DFS traversal from. Now return the max chain length. Now let's create this function. So this is an integer function, because this DFS function is going to give me the maximum starting, let me write it here. So DFS of nth node is going to give me maximum, or let's say longest chain starting from the nth node. Okay, let's see. So vector reference graph, then you need a string references, then you need a node, and then you need a reference variable, that is max chain length. Now you need two variables. So why we need two variables, I will explain you. So first of all, we are going to have longest chain, or let's say longest child chain, that is initialized with 0. Then we have second longest child chain, that is also initialized with 0. Now int child from graph of child. Now we have another variable, that is chain length, and it is not initialized with anything because it will have its own value. Now chain length is equal to 1 plus of DFS. Now DFS to, so graph as it is, S as it is. Now this node is going to be child, and max chain length as it is. Now there's a condition, if S of child is equal to S of node, right? This situation says that if A0, that is S of 0, that is A, and S of 2, that is A also, is equal to, I mean, both of the characters are same, then we don't need to do any computation. This path will be rejected and we won't be going from 0, we won't be going to 2, and we are going to continue. But if it is fine, then we have two things. Then there will be two scenarios. If now the chain length that we have got, if it is greater than the longest chain, child chain, then it's well, it's not a problem, but we need to change some values. So first of all, second longest chain length will have the longest chain length, and the longest chain, child chain, will have the value of chain length, right? Else if chain length is not greater than the longest chain length, but it is greater than the second longest chain length, then second longest chain length will be equal to chain length. Fine. Now when we are done with these computation, then I will say, now let's note the maximum chain length that is encountered in the DFS traversal on each of the nodes. So chain length will be max chain length will be equal to max of max chain length, and now the longest chain length that you have, longest child chain that you have obtained, and the second longest child chain that you have obtained plus one, the node itself, and we will be returning the longest child chain. Let's see if this will work. Okay, this should be node. Graph. Okay, this should be parent. Okay, it is passing the test cases. Okay, it is submitted and it is performing quite well. So yeah, it's good. Now let's understand how this is working. So let me give you a dry run of this code on over this test case. So let's say we start with DFS of let's say the solve function, right? This solve function, and it starts with 0, and the character that it has is A. Now this A character, so let's say just start with solve of 0, okay? And yes, now, so if it is child, now chain length is equal to 1 plus of second of S of 2. Fine. Now S of 2 will be then computed as 1 plus of S of 5. Okay. Then S of 5. Now S of 5 doesn't have any value, which means this for loop will not be run, and max, and it will return the longest child chain, which is not changed, and it was initialized with 0, which means it will return 0 value. So when this is 0, S of 5 is 0, this value will be 1 plus 0, and 1 plus 0 is 1, which means S of 2 is now going to be 1, and 1 plus 1 is going to be 2. You must be saying that when I go to 2, S of 2, 1 plus S of 2, this value is equal to 2. Fine. But you won't be having it. Why you won't be having it? Because now you have an S of child, this condition that will take control, that if S of child is equal to S of node, that is S of, at this position you will check S of 2 is equal to S of node, that is 0. Now what is the S of 2 value? S of 2 value is 0, 1, 2, that is A. and s of 0 value is also a, which means they are equal, and we will continue the loop, we will not do anything. So the length, the chain length at this point is equal to 2, but you wouldn't do anything about that chain length. Why? Because you cannot do anything, right? You will not be able to add anything to the answer, because that is not an acceptable length, first of all. And why it is not an acceptable length, and but still we have to do it. You will be saying that why not, why we shouldn't have this condition like this, right? So that we don't have to compute this DFS. No, we have to do this, and there's a very profound reason for that. So let's say that a22 is not a valid length, and you stop the execution at this point only. But there is a possibility that from this node there could be a max chain, right? There could be a max chain from this node, and but you didn't check it. Why? Because it was giving you an error at this point, which is why this is a very trivial thing that took me some time to catch. But yeah, this is a very good observation, that the DFS call should be made prior to the condition, if the checking that if s of child and s of node are equal. Now let's backtrack to s of 0, and then you will have 1 plus of the second node, that is s of 1, the other child. And s of 1, you will say that okay, you will go to 3, 1 plus of s of 3, and from s of 3 you don't have anything, so you will return 0. Now if it is 0, then it will be equal to 1 plus of 0, so this will be 1, and s of 1 is equal to 1, and now this is going to give you a value of 2. So when this will give you the value of 2 and it is done, then you will go to this condition, s of child is equal to s of node. Is this the case? Well, s of 0, which is equal to a, and s of 1, which is equal to b, they are not equal to each other, right? Which means yes, we don't have to go into this condition, and we can directly jump to this part. Now chain length, this point, chain length is equal to 2, right? This is the chain length, and the longest chain length is equal to 0, which means longest chain length now will be 2, and second longest chain length is now going to be 0 at this point. Okay, so now we have these values, so let's start. Yes, and yeah, so the s of 3 will give you 0, and this will be 1, this will be 1 plus 1, that is 2, and okay, now because we are adding this value, that is at this point the longest child chain is equal to 2, the second longest child chain is 0, but we are adding 1, which means we are adding 1, and this is equal to max chain length is equal to 3 at this point, right? And now you will be done with your execution. You don't have, I mean, there is another way, but you can also but it will be cancelled out because it has same characters, and you can try it by yourself. I think it must make some sense, and it is much more simpler than earlier. So yeah, after this part, now you will be returning the longest child chain. Now you may have a question that why we are returning the longest child chain. So let's say you have this node that is n, and you have a child node that is k, and then you have a child node that is l. If you want this n node to be included in k and l, then this case shouldn't give you a node like this, that this chain is like something like this, right? Because if you are including it like this, then this is a chain of itself. You cannot include n in it now. So this should give you, a k should give you a maximum chain length that is starting from k, which is why you are returning longest child chain, not the maximum chain length. So this is the main reason. And if we talk about the time and space complexity, I have discussed it already. So these are the time and space. Now if you want to check, if you have any doubts, you can obviously ask in the comment section, and you can obviously try this problem now yourself. And if you still have some doubts or some queries, and or want to get some hints, then you can refer the solution that I have um, written for this problem. So yeah, this is the problem, and thanks for watching. Have a good day.